Okay, in this short video, I want to just focus on the equation of motion, but for a system of particles. So I know that this is 13.3. If you go and look in your textbook, it speaks about system of particles, but I just felt I did cover it briefly in one of the previous videos, but I just wanted to kind of focus on this, but focus on it with a view to solving the problems, because I think the textbook, although it's an excellent description and it gives everything in nice detail, sometimes it's difficult to take the abstract and apply it to a real life problem. So basically, if you've got say a block, let's just talk about that. Say you got a block, one block, and it has a mass, okay? Then and there's a force acting on it, okay? Then we know that this is basically it's a single particle, a single body, a single particle, okay? So what do we do? How do we analyze it? Well, in a very rough sense, sum of the forces is mass times acceleration, okay? And we solve it how we would normally solve these problems, okay? Now, what do we notice here again? It's a single particle. And so what I want you to take note of when I'm trying to describe this is what does this refer to? The sum of the forces. Okay, so that's one thing you need to take note of. What is the mass? Okay, what do we mean when we talk about the mass? What do we mean when we talk about the forces? And based on this, what do we mean when we say system? This is a word that you must pick up, system. And external and internal forces. Okay? This is so crucial even for the rest of your studies, is to understand what is a system and what are external and internal forces. So a system is just what makes up all the particles. So in this case, we've got one particle, right? And this now is our system. That's our system. Okay? And in our system, we've got one particle, and the mass here in this equation, please take note, refers to the total mass of the system. So that is the mass of the system. What about the forces now? The forces are, and this is important, guys, the forces are all the external forces. So when we're talking about this equation, sum of the forces is mass times acceleration. The forces on this left-hand side of the equation are only external forces to the system. Okay, so for example, here we would also have the normal force, and we would have mg, right? Okay, so when we talk about for this system, the external forces would be these forces that are acting externally, right, on the system. Okay, but I'll go into more detail. And then the mass is the mass of the system. Okay, now what happens if I've got one block there and it's attached now to another block? So I've got mass 1, mass 2, and I've still got that same force P. Okay, now again, sum of the forces is mass times acceleration. Okay, the first thing we need to do when we are working with this equation is we need to define our system. That's the first thing. Right, it's obvious when we're working with a single particle what our system is, right? You don't even need to think about it. You've been doing it automatically. You've been defining your system. You've just been looking at that one particle, and this applies just to that one particle. But now we've got more than one particle, so we've got a system of particles. We need to define what is our system. Okay, so because we're working with both of these particles, both these bodies, let's define this as our system. Okay? Which means what? So, well, number 2, we now need to, based on the system we have defined, there's our system. It includes both of these particles. Now, how do we make use of this equation of motion? What does this now refer to? This refers to all the external forces to the system, forces that are external to the system. What are the external forces? It's P, right? P is the only force that is external to the system. Okay, I know you can talk about gravity and normal forces. Okay, I understand that. But just for time's sake. And now, what is the mass? This is the mass of the system. It's the mass of the system. What is the mass of the system? M1 plus M2. So we're going to have P here. Okay, I'm just going to put a vector there because I'm not going to break it up into its X and Y and everything. Okay, but P is now M1 plus M2 times the acceleration. Guys, so please take note. Define your system. Okay, I'm looking at this system here. Okay, then when I write out my equation of motion, this refers only to the forces that are acting external to the system, or another way to say it is on this system. So imagine you ignore this and you just draw that, right? There's P acting on this system. What is the mass? The mass refers to the mass of the system, which is all the mass particles inside. Okay? And also then you notice the acceleration is equal to that P over M1 plus M2. Okay? So the whole system is accelerating with an acceleration of A. Okay? So both of these particles then accelerate with the same acceleration. Now, I know I mentioned here internal forces. Let's have a look here. Say now, I want to know what is this force between M1 and M2? What are you going to do? Well, you define a new system. Let's say I want to know what is the force over here. This tension force, or this force in this beam, or whatever is joining these two things, these two masses. Let's take M2 as my system, right? I just extract M2 and I draw a free body diagram of M2 only. So if I draw M1 here, and there's M2, what is the force that M1 is exerting on M2? Well, it's going to be, it looks something like this. F, that 1 is exerting on 2. And what is the force that block 2 is exerting on block 1? It will be an equal and opposite force, block 2 on block 1. So can you see that if I took this as my system, these two forces are internal and would cancel each other out? I hope you can see that. The forces between the particles in the system are internal forces and they cancel each other out. But if I want to know what is that force between those two, I isolate just that mass, that particle, and that becomes my new system. And so now I've got F, let's redraw it here. I've got that force there, F1 on, acting on 2, and I've got P. And so now, sum of the forces is mass times acceleration. What I'm now just looking at mass 2. Okay? I'm only looking, because that is my new system. So what are my forces now? Now I've got minus F1, 2, right? Plus P is, what's my mass now? It's the mass of the system, M2 times acceleration. Okay? Okay, so please take note of external, internal forces. What is this? What is the system I'm talking about, and what is the mass? Okay, so in the next video, I will do an example. I'll do a few more videos to highlight this kind of problem. Thanks.